Start recording it right now, so you'll have it on YouTube. All right, let's solve that thing. So here we go. What do you do? Do you remember to solve an equation? To graph something. What do you do to graph? Get y alone. Get y alone. Yeah. So for graphing, and you have a 3x5 card, right? So I'm going to suggest things as we go through. What you might want to do right now is on a separate piece of paper, aside from your, one of your note papers, on a separate piece, write, formula sheet or whatever, right now, and start writing down the things as we go through, as many of these as we can in the next hour and 20 minutes, as many as we can. I'll tell you, hey, this might be a good thing. Some of the things you'll think, no, I don't need that. I know that. I got that cold. Great. Then, it's going to be different for everybody. But I'll make a bunch of suggestions what you might want to put on your 3x5 card. So for now, you can just make a big list of stuff on a paper and then make the 3x5 card later if you want. So one thing you might want to put is whenever you graph, step 1 is get y alone. Step 2 is y equals mx plus b. We start with the number that's out there. But maybe you're like, I know that. I don't need to write that down. Great. Maybe so. So I'm going to take this equation. X plus 2y is 4. So what am I going to do to get y alone? What do I do first? Yeah, I just like to jump things, but you're right. Subtract the x is the same thing. When we jump something to the other side of the equal sign, what happens? Signs change. So it becomes negative x plus 4. See how that 4, the 4 had no sign in front of him, which is plus all along, right? And now, what do I do to finish getting y alone? Divide by the 2. Remember, when you divide, you do all 3 of them, huh? All 3 like that. So y equals minus x plus 2 over 2. 4 divided by 2 is 2. So there we go. Okay, so let's graph that thing. So how do we graph it? Where do we start? Yeah, start. And that's up to, so it's right here, huh? That's the y-intercept. Good so far? And then where do we go from there to find our next dot? We're halfway there. We got one dot. We just need one more. Yeah, this has an invisible negative 1 there. That's rise over run. So we go down 1, over 2. There's the second dot. Everybody good with that one? Down 1, over 2. And then just connect the dots, huh? So I'll just connect the dots. There's the line. And we got it. So on the multiple choice test, you'll just look for the one that looks like that. We good? Questions on that one? All right. So number 3, they say use the graph to find the following, f of 0. So what they want me to do, this is the graph over here of f, the function. And they want me to somehow take that graph and find f of 0. Like, it's kind of a weird question. What do they want me to do? Well, the key is to remember that whatever's in the parentheses is x, and whatever it equals is y on the graph. So I say, okay, go find the dot, go find the point that has an x value of 0, right? X is 0. That'd be right there at the origin, huh? That's the dot. Because these are x values, right? 0, 1, 2, 3, 4. These numbers. These are x values, right? So find the, because it's the x-axis here. And this is the y-axis. So find the dot with the x value of 0 and tell me. So that dot right there, what's the coordinates of that dot? 0, 0. So the x0 goes what? So the answer is 0, huh? The x0 goes with y0 at the origin. Now that's kind of a silly question. Let me give you a different one, because on the real exam you might get a different one. What if they said f of 3? How about we do that real quick? Let's answer that one. So use the graph, find f of 3. So you want to look at the graph and find the dot that has an x value of 3. Find the dot that has an x value of 3. So let me get kind of rid of these marks here. Here's a 1, 2, 3. Here's 3. So go up, 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 up. Boom. Well, I don't know. It's hard for me to tell. Maybe it's here. It's not, I would make it super clear on the exam. I'm just making up another problem, and it's hard to tell. But let's say it's about right there. It'll be clear on the test. But maybe it's there. So what's the coordinates of that dot? Over 3 up 5. So that would be x, y. So this would equal 5. This is making sense? So whatever number they put in the parentheses, that's x. Go to that x value, go up to the graph, find the dot, give them the y value that goes with that x value at that dot on the graph. That's what they want on that. So there's nothing to calculate, nothing to add, subtract, multiply, divide. It's just find that dot on the graph, give them the y value. What's the domain? Let's answer that question. Yeah, domain is the width. You know, left edge, right edge. How far left and right? The width is the domain. So what's the width of that graph? How far left, how far right does that graph go?
-3 and 4.
Yeah, it goes from -3 here to, what is it?
4.
Oh yeah, 4, doesn't it? To 4. So -3 to 4? So that one right there, huh? Okay, we good there? Okay, the thing that people don't like on my exam, I'll just tell you ahead of time, is they really don't like is the none of the above option. So I put the none of the above on there because I have to make sure you really do know stuff and you're not just guessing your way through the test. And some of the answers are none of the above. Not a lot of them, maybe 4 or 5, but 4 or 5 of them on the exam are probably none of the above. It's usually well, maybe 3 or 4, somewhere in there. 3 or 4 probably are none of the above. So sometimes it is none of the above. It's always really frustrating when it is. People always say, "Oh, Mr. Hanna, I hate none of them," including my own son who's taking some of my tests at home. Like, "Dad, why do you do the none of the above?" All right, anyway, so watch out. Be ready for that. I don't want to surprise you. All right, so what is the set? What is the set of x values such that f of x is -4? Okay, so try that and get this stuff out of the way. So see if you can read that off the graph. Yeah, that's a good one. So it's all about like speaking their language, huh? It's kind of a weird language. Let me help you. Remember the key to speaking their language, this is x and this is y. Remember what's in the parentheses is x, what it equals is y. So they're basically saying, hey, go to the graph and find the place where you've got a y, the dot, the dot on the graph, that has a y value of -4. Do you see that dot? And give us the x value, please, that's going with that dot. So do you see the dot right here? At a y value of -4, that dot. And what is the x value of that point? -2. -2. Is that making sense? Are you speaking their language? These ones are mainly about speaking the language they're speaking, huh? They're giving you a y, they want an x. Next question, what is the range? Up and down, very good. Up and down, that's the range. So what's the up and down? How low does it go? How high does it go? It's like -9, +8. There it is. -9, +8. And we're done with that question. Good with number 3? Questions I can answer on number 3? All right, we can do number 4. There's nothing more to it. Find the slope and the y-intercept. How do you find the slope and the y-intercept? What do you do to find the slope and the y-intercept? You just solve for y like you're graphing. Just pretend you're graphing. Just go ahead and take that equation and get y alone. And then the slope will be the number next to x, and the y-intercept will be that other number further off to the right. Does that make sense? So go ahead and take this equation. Just get y alone. Just pretend you're graphing, and you always get y alone first. So if we take equation 7x minus 5y6, and we get y alone, what's our first step to get y alone? 7x, jump it over. What does that 7x become on the other side? Negative 7x. Last step to get y alone. Divide, and we divide by the exact same number, huh? And then we do it with all three, don't we? Whenever we divide all three like that. Okay, and so we can clean that up a little bit. So right here, what do these two negatives do? Yeah, two negatives always become positive, huh? We good with that? Oh, you're right. Only multiplying or dividing. Yeah, you're right. Yeah, not adding, subtracting. Yeah, multiplying and dividing. Always multiply. Yeah, multiplying and dividing rules always go together. Multiplying and dividing always do the same thing as each other. And adding, subtracting do the same thing as each other. Different than multiplying and dividing. Yeah, there's always two sets of rules for everything, huh? How we multiply, divide those things, and how we add or subtract those things. Yeah, so for dividing, the two negatives cancel. It's positive 7/5 x, and this is 6 over minus 5. So what's the slope then? Yeah, the slope is right there. That's the slope, and what's the y-intercept? It's that other number, huh? Minus 6/5. By the way, notice how I took that minus from the bottom, and I put it in the front. You don't have to. It's fine either way. You can put it top, bottom, front. It's all the same thing. I hope you're comfortable with that because, especially in the exam, it's multiple choice, right? So they might move it somewhere else. I don't want you to be thrown off by that. So you'll know, oh, it's all the same. It doesn't matter where. If there's just one minus sign. Now, two minuses, that's plus. That's what we did there, right? Two minuses is plus when you're dividing or multiplying. But if you just have one minus sign on a fraction, it doesn't matter where that minus sign is. Bottom, top, front, whatever. It's all the same. I just put it in the front. Good enough. Is that good? So when they say find the slope, find the y-intercept, just solve for y. And the slope is the first thing. And the y-intercept is the second thing, just like when we graph. Good. Questions? Okay, so how are we going to find the slope of that line? We could, yeah. Right, that's true. How about, could we just do it to make it easier and quicker? Could we just go, see how they're highlighting that dot and highlighting that dot for us? Could we just do, remember, what is slope formula? I mean, it is the y2 minus 1, that's true, but even simpler. Yeah, remember it's rise over run, huh? So that would just maybe save us some time. Can you just start it? It doesn't matter which one you start it, just maybe start at the top one. And go down to the bottom and do rise over run, just count the dots there. Can you do that real quick? Let you try that and then I'll finish it. So it'd be, 1, 2, 3, 4, 5, 6, 7, 8, 9. So down 9 over 1, 2, 3, 4 over 4. So the slope is down 9 over 4. Minus 9/4. We all good with that? So remember, positive is up. I think you know negative is down. Positive is right. And left is negative, huh? So I could have gone the other way, and it would have been correct also. In other words, I could have started from the bottom. It doesn't matter which one you start with. You go 1, 2, 3, 4, 5, 6, 7, 8, 9. I went up 9, so that'd be positive, huh? But now I'm going to go left. 1, 2, 3, 4. So that's negative. So it's the same thing. It's still 9 over negative 4. And that doesn't, negative in the bottom, negative in the top, negative in the front, whatever. 1 minus on a fraction, doesn't matter where it's at. Same answer, either way. We good there? Doesn't matter whether you go top to bottom or bottom to top, as long as you remember Positive is up, negative is down. Right is positive and left is negative. Okay. Want to try number 6 there? Fine. So now they're giving you the 4 numbers. Remember how to do the slope when they give you the 4 numbers? So that might be a good one to put on your 3x5 card. That's going to be the y2 minus y1 over x2 minus x1. Remember that formula for slope? So good one. So I'm making another suggestion. So if you want to write over on your, your 3x5 card information, slope formula. We'll see how I'm just, as we go over the practice exam, anything I need, or you need, just put it on the 3x5 card as you do the practice exam. Then you will have covered everything. So now what's the x1, x2, all that stuff? This is x1, y1, x2, y2. So we're doing y2 minus y1. So minus 13 minus 7. Is that making sense so far? y2 minus y1. Over x2 minus x1. Everybody good with all that? So y2 minus y1 over x2 minus x1. And you know the double negatives become positive kind of stuff, right? And so we get, what do we get there? So these two are going to become positive. These two are going to become positive, right? 2 negatives head to head like that. Positive. Then just use your calculator. I think, what do you get? Minus 6 over minus 1. Is that right? Which is positive 6, huh? Answer 6. Everybody good with that? Positive 6. 2 negatives became positive. Excuse me, and we never leave a 1 in the bottom of a fraction, do we? Considered unsimplified, we just make it 6. 1 just goes into 6 times, huh? So we just write it that way. Is that good? Questions on that one? 10. So 2 times f of x plus 8 equals 10. So they want me to graph it. Now, what do we do with f of x? Yeah, remember the whole f of x becomes y. So if you need to, there'd be another thing to put on your 3x5 card. Perhaps. So now what do we do to graph it from there? What do we always do for graphing? Get y alone. So go ahead and do that. Some of it might be helpful for you to have. Okay, so solve for y. So subtract 8 from both sides. And we these go on. So 2y is 2. Last step to get y alone, divide by 2. Y is 1. Okay, now, how do you graph when you just have like one number like that? We don't, it's not like the normal one where we have an x and all that. What do we do? Yeah, it's going to be a straight horizontal or vertical line, and you just go right through the y-axis. This is y equals 1, huh? Just hit, where's y equals 1? Right here, huh? And just put a line right through the y-axis at 1. Does that make sense there? I went right through the y-axis at 1. Good on that? You can do that on the test. Questions? So I just solved for y. F of x is just y. That's how they were trying to trick us. Remember, f of x, the whole f of x becomes y. The f, the parentheses, the x, the whole thing just becomes y. They asked about slope. I didn't, yeah, they want me to graph it, then they want me to say slope. Thank you. Yeah, what is the slope? Yeah, the slope is 0 for a flat line like that. Slope is 0. If you happen to have a vertical line, because, yeah, sometimes we have those, don't we? It's undefined. Good thing. I'll put that up on the board, too. Vertical line, if you have a vertical line, slope is not 0, but it's undefined. Yeah. If you have a vertical line that goes straight up and down, that's an undefined slope on that. Good, thanks. I didn't notice that part of the question.
So the vertical line is straight up.
What's that? Vertical line straight up and down? Yeah, so if it's a straight up and down vertical line, that's slope undefined. Undefined means it's so big, it's like infinity, we couldn't even give it a number. All right, but this is a flat line, so slope 0. All right, okay, so there it is, try number 9. There's the equation up there. Normally we get y alone, right? But there's no y, is there? So just get x alone. That's all you got is x. So just go ahead and get x alone on that one. And then graph. Okay, so yeah, so if we want to take that equation, I'll bring it over here. We'll have a little room. 4 minus 2x is 8 plus 6. How do you solve for x when it's on both sides of the equal sign like that? Yeah, get them all on one side. Huh? Get rid of one of them. It doesn't really matter which one, so you got to get rid of them. So I can do the opposite of that one. Or you could have done minus 3x and got rid of the 3x. It doesn't matter. Just get rid of one of them. Get one of them out of there. And so then we'll have 4 equals 8 plus 5x. And then subtract 8 from both sides. And this is what? Minus 4 is 5x. Last step to get x alone. Divide. Yeah, last step to divide, huh? X is minus 4/5. X is minus 4/5. So minus 4/5. So that's our slope. Minus 4 over 5. Rise over run. Is that right? Good. That's crazy what I just did, but I see that mistake a lot. Yeah. Good. What's wrong? Isn't this the slope? No. No, slope is only, remember, so it's on the board still. Slope is only when you have y alone, look at the fraction next to x. That's not what's going on here, right? First off, there is no y in this problem, right? Slope is if you have y alone, and then the rise over run, the slope right here, is what's next to x, and then there's some other number out there, right? That's where you see slope in an equation, is it's the fraction next to x when y is alone. You can't just say, well, it's any old fraction I see anywhere at any time. That's not true. It's not any old fraction anywhere at any time. It's fractions next to x when y is alone. Well, you think, well, yeah, but I don't have a y here. Right, so that's not your slope. You with me? So watch out for that mistake. That's an easy mistake to make. Well, what are we supposed to do then? What is the slope? Well, let's graph it first, and then I think the slope will come naturally. So there's our equation. You agree to there? I'm going to erase the work. Is that okay? So x equals negative 4/5. How do we graph that then? Is that the rise and run? It's not, because again, that's not next to x. That's on the other side of the equal sign from x. Well, what do we do with that? Well, that's actually a number. If you divide that in your calculator, you can use your calculators during the exam. Bring your calculator. No cell phones, of course, right? Because you could beam answers around to each other, right? Or your friends back home. So 0.8. You divide 4, just go 4 divided by 5 equals. And you'll get that that's 0.8. It's negative also, so it's negative 0.8. Does that help? So basically, I'm going to put a line through the x-axis, right? This is the x-axis, this is the y-axis. I'm going to put a line through the x. Now, where is that? Well, this is 1, 2, negative 1. So where is negative 0.8? Well, yeah, it's almost to negative 1. It's about right there, negative 0.8. It's almost to negative 1, huh? Does that make sense? Which one has a line a little bit left of the center, almost to negative 1? Okay, see how that line is almost to negative 1 there? Whereas this line is on the right side, this is a flat line, and this is a diagonal line. You see how we got it? And now that we know it's a vertical line. What's the slope of vertical line? Undefined is the real slope. So slope undefined. Everybody good with that? So don't let that fraction throw you off. It really can, huh? It's kind of tricky. Just remember that's not a slope. Why is it not a slope?
Because it's not y.
It's not next to x, and there's not a y, right? It's got to both have a y, and that's got to be the fraction next to x, right? It's not that. So then what is it? We'll just divide it, make it a decimal so it's easier to look at. You don't have to, but I think that'd be easier. Minus 0.8, and just go, oh, it's just the line going through the x-axis at negative 0.8, almost to negative 1. Good? So that won't trick anybody now, I'm hoping. Okay, so how do they give you a couple equations? How do you figure out if those I don't want to graph them. How do you figure out if those equations would produce lines that are perpendicular? What does that mean, lines that are perpendicular?
Opposite each other.
Yeah, like an intersection, right? Streets that cross in opposite directions, like an intersection. So they're basically saying, hey, if you graphed them, we're not going to graph them. But if you did graph them, would the two lines be like at an intersection, opposite directions, yes or no? How do we figure that out without graphing? Because we don't want to take the time to graph everything in the world.
Just get the
Slope. It's all about the slope. Yeah, so go ahead. So how do you find slope? Get y alone. Yeah, so get y alone on both those. So go ahead and get y alone in both those, and then compare the slopes. I'm going to get y alone in both equations, and the slope will be the fraction next to x. So I'll jump this x over there. So we'll have 2y is negative x plus 3. Finish getting y alone, divide by the 2. And so we have y equals negative x over 2 plus 3 halves. So what's the slope there? Negative 1 over 2. Negative. So there's the slope for that one, right? It's the fraction next to x after you get y alone. Let's do the second equation now. So for this one, jump the 2x over, and we get, 4y is minus 2x plus 5, and then divide through by 4. Y equals minus 2/4 x plus 5/4. And what do we do with that minus 2/4? Yeah, you always reduce fractions. So make it 1. Divide top and bottom by 2 there. Make it a half. We good so far? Everybody good? So I got y alone in both equations. So this one is, so this slope is negative a half. The other one's slope is negative a half. So they have equal slopes, don't they? So are they perpendicular? No, they're parallel. So they're not perpendicular. Perpendicular, they have to be upside down. So one of them would have to be minus half. The other would have to be plus 2 over 1. Right? For perpendicular, you have to have one negative, one positive. They have to be opposite in every way. One negative, one positive. One's a half, the other's 2 over 1, or just 2. Same thing. Upside down. They've got to be upside down and opposite sign. One positive, one negative. Opposite in every way to be perpendicular. So parallel means exactly the same. Perpendicular means totally the opposite. Right? Like two streets that go exactly the same direction, or like an intersection, totally opposite directions. Opposite sign and opposite upside down is what's required for perpendicular. These are parallel, so they're not perpendicular. Good? Questions? On to number 11. 11's important. So let me write it out. M equals 5/6. And the point is 4 negative 6. And they say those magic words, find the equation. Okay. How do we do it? So there'll be probably 3 questions on the exam Wednesday that say these magic words. That's a lot of the battle, isn't it? The identification. That's what I want to help you with. It can kind of all look alike. So that's what I'm trying to help you today with. When you see those words, find the equation. That's where you have to do the, what do? You do the slope equals y minus blank over x minus blank thing, step 1, and then cross multiply, and step 3, solve for y. So that's the game plan. Whenever you see the words, and we'll do 3 of them today, find the equation. Find the equation. So can you do that? So let me do the first step with you. So over here, step number 1. So I'm going to write, whoops. I'm going to write slope equals y minus over x minus. And so I grab that slope, put it there, and so we get 5, 6 equals y minus x minus. Okay, and then where am I going to put the x and y values? Behind the x and the y, right in the blanks. Careful not to mess up the order, though. Remember, this is x, this is y, so yeah. It's it's an easy mistake I've seen over the years a lot. Is people just grab the first one. It's kind of natural, you just think, oh, grab the first one. But careful, that's the wrong spot, huh? Because that x has to go behind x, not behind y. So watch out, the first one actually goes on the bottom, and the second on the top. See what I mean there? Because x has to go behind x, and y behind y. So watch out that you don't reverse that. With enough practice, you'll be good. So we put that in place. So there's step 1. Can you do step 2 now and cross multiply? Diagonal, diagonal. Remember that and solve for y. I'll let you. Okay there, so I'm going to cross multiply. So I wrote up extra instructions. I'll explain those in a minute for the harder version. We're on the easiest version of this right now. There's 2 versions that are harder. So those cover all that. We don't even need that big old step 0 right now. This problem not required, will be required in a minute on a couple others. We just need step 1, 2, 3, right? Slope, cross multiply, solve for y. So slope, so we cross multiply now. So I'm on step 2 now, cross multiply. 5x minus 4, 6, y plus 6, right? These 2 negatives here become positive. Is that good? Like that. So I just go diagonal, diagonal. Does that make sense? And then distribute. 5x minus 20. 6y plus 36. So what do we do to get y alone? Subtract the 36. Is that minus 56? Yeah. And then last step, divide by 6. So that means y equals 56x minus 56, except one little tiny thing left. What? Reduce that fraction, right? We can't leave 56 over 6 whenever we have fractions that need to be reduced. Got to do that. So they both divide by 2. Is it just 2? I think. 28/3. There we go. Some of y'all have calculators that'll do that automatically, right? Just it'll reduce those fractions automatically. No? Maybe? We good to there? So there it is. So we got the equation of that one. Oh, get off the screen. Is that good? Questions I can answer on that one? Right, slope equals y minus blank over x minus blank, right? With the blanks, cross multiply, get y alone. There's the equation. That's when they say the magic words, find the equation. Find the equation. All right, we'll do 2 more of those, even harder than this one. The only difference between those other 2 and this one will be we'll have like a step 0 where you have to first find the slope. They won't give me the slope. See, on this one, they just handed me the slope right here. You know, real easy to use. But in the other ones, they're not going to give me the slope. I'll have to work for the slope.
That's where you have to do it twice.
Yeah, twice.
And then you
Exactly.
get it.
Right. Exactly. Okay, so find the equation. So there's those same magic words, find the equation, right? So when we see those words, find the equation, what do? We do a step 0 where we do slope equals y2 minus y1 over x2 minus x1, right? That's what I'm saying up here with the previous, call it step 0, where you got to first find the slope using all 4 numbers, because they're not giving me the slope this time. See the difference? See how on the last one they just handed me the slope right away, 5, 6, you know? But on this one, they're not giving me the slope, so I have to get it myself using those 4 numbers. So go ahead, so let's get ourselves a slope. Slope equals, can you get that first off? So get the slope, and then just do the same 3 steps that we did last time. So you're going to use the slope formula twice. Like Rose was saying, we're going to use it twice, huh? We're going to use it, so we use it now, and then we're going to use it again with the blanks in the back, where we just put 2 numbers in the back. And it doesn't matter which 2. You can do the first 2 or the last 2, it doesn't matter. We're going to use it a second time. It's a double sloper. So use the slope formula again. So this is x1, y1, x2, y2. So y2 minus y1, 3 minus 2 over x2 minus x1, 3 minus 1. I'm getting 1/2, slope 1/2. That good? So that's step 0, and then step 1, now we write the slope formula again, but this time with just a plain y and plain x and blanks in the back, huh? Is that good? And you grab the slope and you plug it in right there. And then what do you put in the back of the y and the x?
Any of those?
Either 2. Yeah, I usually just grab the first 2. You don't need all 4 this time, right? The second time you're only using 2 numbers. You don't use all 4. So, but careful, make sure you put the x behind the x and the y behind the y. Don't reverse those. I'll let you do that. Take it from there. Cross multiply, solve for y again. So I'm going to grab the 1, 2. The 2 goes behind y, the 1 behind x. We good there? And then we go diagonal, diagonal. Step 2, cross multiply. 1 times x minus 1 is 2 times y minus 2. You getting the hang of this? And then just multiply and solve for y. So distribute x minus 1, distribute 2y minus 4. So we got to get y alone, bring it up here. So now step 3, we have x minus 1, 2y minus 4. And here's the wall, and y is saying I want to be alone. So add the 4. We always get y alone in the end here. Boom. And we get x plus 3 is 2y. Step divided by 2. Remember when we divide all three of them, huh? So there we go. We got the equation. So you see how it's almost just like the last one. It just has an extra step 0 where you have to do all four numbers to get the slope because they didn't give you slope. And the rest, you use the slope formula again with the blanks in the back, which is two numbers. Cross multiply, solve for y. We'll do one more of this. Then you'll all be pros at these. Good? Questions I can answer? Okay. And then the same three magic words. Find the equation. Okay. So this is so it's going to end the same. You know, step 1, 2, and 3 are all going to be the same, but we have a step 0 here. Again, a little different than the last step 0. Why do we have a step 0? Because they're not giving me the slope. Huh? Like, where's the slope? I always need the slope. I don't see any slope. I need to get a slope. So how do you get a slope? What could you do with that equation to get it to give you a slope? Yeah, get y alone. Remember how we did it? And that's what I'm explaining up here. I'm saying get your slope on step 0. Find a slope if not given. By either the four numbers, but I don't have the four numbers this time. Or for the perpendicular kind of case, that's what this is. Get y alone, slope is next to x, then flip that fraction and change the sign. Why? Why do I flip the fraction and change the sign? Because perpendicular means upside down, opposite sign. Remember? So that's what we do. So let me write that out. So step 0, find the slope by get y alone, slope next to x, but it's perpendicular. So flip it and change the sign. Does that make sense? It's not the right slope at first. Our line is perpendicular to that slope. So it's opposite of that slope. So when we get the slope that comes out of this equation, to get our slope, we got to take that one and flip it and change the sign. Is that good? Let's do it. So let's take this equation, the 9x plus 7y is 3. And we've got to get y alone, slope is next to x, and then flip it and change the sign. So get y alone there, and you'll get the slope of that equation, which is different than our slope because of the perpendicular. So get y alone, the slope will be next to x. Jump it over. Get y alone. Okay, so minus 9/7, that's the slope of the other equation. Minus 9/7 is the slope of the other equation. So what's our slope? Our slope would be flip and change the sign. Positive 7/9. Is that good? I took this thing and I flipped it and I changed the sign. Positive 7/9. So our slope is positive 7/9. So then now the rest of the problem is the same. Step 1, we write slope equals y minus blank over x minus blank. Can you take it from there? Questions on that first part that I can answer? Step 0, how we got. So we took that other equation, got y alone, got that other equation's slope, and turned it into our slope, because Ours is perpendicular to that one by flipping it and changing the sign. What if they had said, and they may, I don't remember which one I put on the exam, but I may have put, that's the one I just skipped, number 13, which you can do. 13, it's exactly the same except instead of perpendicular, it says parallel. So what if they had said, ours is parallel? So what would I do when I got the other equation's slope of minus 9 tenths? I wouldn't flip it and change the sign. That's for perpendicular because those are opposite slopes. What would I do for parallel? Just leave it the same because parallel means same, huh? So that's easier. That's why I'm doing the harder version. So if parallel would be easier, you would just keep the same slope. You would just use minus 9/7, put that on the left, and start moving with the other three steps, right? So if it says parallel, they're the same. Just keep the same slope. If it says perpendicular, that's when you flip it and change the sign. Can you take it from there now? So now do the rest. Same step 1 through 3. Slope equals y minus blank over x minus blank. Put the numbers in the blank. See the numbers up here, the 9 minus 3? They've been waiting patiently to be plugged into the blanks on the right. The x behind x and the y behind y. And now we have the right slope finally. Put that on the left, cross multiply, solve for y. So it's going to be 7/9 equals y minus over x minus, and I'm going to grab, so the x goes behind x, the x of 9 goes behind x, the y of minus 3 goes behind y. Is that good to there? So I'll go to a fresh screen, so step 1, slope equals y minus blank over x minus blank, what was it, 7/9? And what was the number we plugged in? Minus 3 and 9. And then we go diagonal, diagonal. Step 2, cross multiply. 7x minus 9, y. This double negatives here become positive, as you know. And then distribute. Use your calculator if you're rusty on some of these times tables. And so at the very end, step 3, get y alone, huh? So how do we get y alone? I'm going to need to subtract 27. And then I get, what is that, minus 90 there. And then last step, divide by 9. Y equals 7x over 9 minus 10. Whew, there it is. That was a lot of work. That was the hardest version of the find the equation ones. That's as bad as it could be. So there'll be 3 of those on the exam. You know, one of them that's super easy, one of them where you got to do the 4 numbers first to get slope, and one of them with parallel or perpendicular. Is that good? Well, now I feel like you could do those 3. So practice them. You know, this will be on YouTube. You can just go over and over and over on these things. All it takes is hours of your life. Which you got nothing but time, right? Nothing but time. No jobs, no other classes, no relationships. No problems. All right, so number 15. In fact, let me just rewrite it here for us a little bigger. So number 15. 6x plus 3y is negative 15. 6x plus 3y, negative 15. Minus 4x plus y, 37. Okay. So how do I solve those 2 equations? We've learned 2 ways. I don't care how you do it. Any way is totally good by me. So the 2 ways we've learned to make them opposites. And then we've also learned get x or y alone and plug into the other equation. I found that students like that second way better usually. So let me just do that. You could, if we wanted to do the plug into the other equation method, how would we do that? So which letter would be, look at the 4 different, 2 x's, 2 y's, look at them all. Which one would be easiest to get alone?
The y, so it's already by itself.
Yeah, that y on the bottom equation is already by itself, huh? Well, I mean, you just got to move the minus 4x over, right? That'll be easy. So just start with that one. Get y alone in that second equation, and then plug it in for y up in the first equation. That'll probably be the easiest way to do this problem. So let's do that. So I'm going to grab that minus 4x, jump it over. So then y will equal plus, it becomes plus, doesn't it? When it jumps to the other side, switches signs. And now take that, remember you always plug into the opposite equation, right? You always plug into the opposite equation. So that's the second equation. Plug that into the first equation. Right there. I always plug in the opposite equation. Boom, there it is. From there, you can solve for x and solve for y. Is that good? So I plugged in into the y slot. I plugged in the whole 4x plus 37 because y is 4x plus 37. It's equal to 4x plus 37. Bless you, Rose. And I just pop it right in there into the other equation in the y slot. Oh, what did I do? Yeah, thanks. I'm just being crazy. Thanks. I was testing you. Well done. Yeah, that should be 3, huh? Not 2. What am I doing? Yeah, there we go. I don't know where I got 2. There's not a 2 on the board or on the screen. Anyway, yeah, that's better. Thank you. So, yeah. So take it from there now. So go ahead and solve for x. Solve for x. Oh, hey.
Can I pass out these at the end of class?
Yeah, or anytime.
Huh?
Yeah, great. Thank you. All right, so let's keep going and solve for x. So what do we got? 6x plus 12x, 90 and 127? Oh, really? Oh, yeah. I'm doing bad math. Yeah. All right, keep going. So what is that? These two make 18x. How do you solve for x there? Subtract 111. 126. Big ugly numbers. Last step divide. I hope that's clean. What is it? 7. All right. It's always encouraging to see a nice clean number come out like that. So x is negative 7. So we've got x. So now, how do we get y? Yeah, plug it in anywhere you want, really. Well, actually, since you want y, what would be the easiest place to plug it in and get y? Yeah, right here where y is already alone. You could plug in anywhere. Anywhere will work, but this would be easy. So I'm going to grab that negative 7 and just go right there for x, huh? So what do we got? Y equals 4 times x, and x is negative 7, like that. And then minus 28 plus 37. Is that minus 9? Minus 11? What is that? I can't tell. I'm having a little trouble. 1, 2, 9. It's just 9. Yeah. 9. So y is 9. So we got x, we got y. On the multiple choice test, it'll just ask you for one of those. Now we good? Okay, let's do one more. Number 16. Now, and again, you don't have to, don't worry about the instructions as far as solve by elimination. I don't care how you do any problem on the test. Don't worry about it. Don't let the instructions, I was saying, sir, I was confused because it's elimination. I was like, do whatever you want to do. So again, we have two equations. How do we solve two equations at the same time? What do we do? Well, this would be, it would be hard to get y or x alone, wouldn't it? Because they all have numbers next to them. See so this would be one where I would do the opposites on. That would be the easiest way. See the difference? Let me look back and help you to, because this is the kind of thing you want to do for yourself as well. I'm trying to show you how to do this. This is exactly what you want to do in getting ready for a math or a science test. This is what I eventually learned to do, is to spend a lot of time looking at the different questions, even after I've answered them, and then noticing the features and going, oh, when they say it this way, I got to do this, but when they say it this other way, this is what you want to do for yourself, which I'm trying to do for you now too. See how it's a lot like the last question as far as, x, y, two equations, everything. But what was easier about 15 is right here, huh? See how there you had a y that had nothing in front of it, no number, a 1 really in front of it, huh? That made him easy to get alone, right? Just jump the 4x to the other side and pop him into the other equation, away we go. Whereas if he had a number, if he had like a 7 in front, you think, well, it's not the end of the world. You could have done it with a number. Yeah, but if I had a 7 in front of it, what would I have then needed to do to get that y alone? How would I have finished? If suppose I just put a new 7 that wasn't really there. What if it really had a 7 in front of it? What would I then need to do to get that y alone? I'd have to divide by the 7. I'd have to get rid of that 7. Then I got fractions. I don't want fractions. So do you see why that would... you don't want it... When you have numbers in front, you don't want to mess with that. That's just going to be difficult. So this one was nice because it didn't have a number in front of it. So if you have an x or a y anywhere, first equation, second equation, wherever, x or y, doesn't matter which one, somewhere you have an x or y that doesn't have a number in front, then work with that. That's the easiest thing to do. Get that alone, plug it in. But see on this one, see how they all have numbers in front? So I would not do, if you get any of those alone, you're going to have fractions. And we don't want to mess with fractions. So instead, let's do the make opposites thing. Remember how we make them opposites and then we add them? Remember that other method we practiced? So you could do the x's or the y's. It doesn't matter at all. How about we just do the x's? How can I make those two x's both become the same number, but one positive, one negative, opposites, so when they add them, they eliminate? Multiply the top by -2. Yeah. That makes sense. Yeah, make that 4 times 2, 8. Like the bottom one, huh? Yeah, so I don't even have to mess with both equations this time. Exactly. So multiply through that top equation by -2. And then what will become of it? Negative 8x, 10y, minus 8. And then the second equation, I'll just bring that down. Hey, they look awfully similar, don't they? But anyway, so far so good. I made the x's opposites. Turns out the y's also became opposites. That wasn't my intention. It's okay. But I just want to make sure you see that first off, I was trying to make the x's opposites. I did make the x's opposites. Remember how to do that? Then we add them up. 0. But lo and behold, the y's also became opposites, and so did the other numbers. What does that mean? What does 0 plus 0 equals 0 mean? Yeah, is it no solution? It's not, yeah, there's two options. This one's infinite solutions. So you want to have on your 3x5 card, if you have 0 plus 0 equals a number, like 7 or 3 or whatever, that's no solution. So you want to have in your 3x5 card, if you have something like that, 0 plus 0 equals 3 or whatever, And the way I remember it, that's not true, right? 0 plus 0 doesn't equal 3. No truth, no solution. So no truth, no solution. Whereas this is true. 0 plus 0 does equal 0. I mean, it's a very simple truth, but it is true. And so we'd expect there to be answers. And there's infinite answers, actually. So those are the two different. Now, a lot of people reverse those, and it messes them up. This question should almost be like a free one for you on the exam if you have that on your 3x5 card. Right? So 003 or something that's no truth, no solution. 000 is infinite. That's infinite solutions. We good there? All right. Didn't we do this problem a week or two ago?
Yeah.
These are just the same problems. Same thing on the test. I mean, it'll be different particular numbers, and it might not be calculators. I mean, sure it won't be. It'll be how many adults and how many children came to the play. That might be it. I sort of have to remember that. Anyway, yeah, it'll be something like that. It'll be two kinds of people and money amounts, and there'll be a money problem. It might be coins. I don't exactly remember. It might be quarters and dimes. So, all right. So how do we do? So the first equation has no money in it. It's no money, no money, no money. Second one's money, money, money. So here we go. First equation. So instead of x and y, I think it's probably easier to use meaningful letters. So I'm going to use what? I'm going to use S, for scientific calculators. Although my S's look like 5s, I'm running a little bit of a risk here. And G for graphing calculators. And that's going to equal the total number of calculators. How many calculators are there? 46. Total number of objects. So that's the first equation. Just x plus y is number of objects. Second equation is the same thing. You just put the money next to each of those. So the money for the scientific is 11. So 11s. The money for the graphing is 55. And then the total money, 1782. The mistake sometimes people make is they'll go 1782 times 46. That's not right? Because it's not saying there's $1782 46 times. It's just 1782 total once. Is that good for our two equations? Is that making sense? So now how do you solve those two equations?
Elimination.
Yeah, or you can do whatever you want. I've noticed it's easier for students usually if you have S, just to get S or G alone in the top equation, plug into the bottom. Want to just do that? So just get S or G alone in the top equation, plug that in to the bottom. You know what I mean? So I'll just jump over the G, for example. And S will equal 46 minus G. Grab that, plug it in there for S. Is that good? So keep going. Take it from there.
You're doing the test right now, right?
Practice test, yeah. Oh, yeah. And when... All right, so plug that in. We get 11 times S. S is 46 minus G plus 55G is 1782. Good to there, right? And then we just distribute. What's that? 504? 506? Thank you. 506 minus 11G plus 55G. 1782. And then we go minus 11G plus 55G is plus 44G. You good with all this solving stuff? Remember all this? And then you got to get G alone. So subtract 506. Is, what's that, 1276? 1276, last step. Divide by 44. Is it 3? What?
29.
Oh, the one I'm thinking is way off. 3. All right, 29. Thank you. I'm obviously not a human calculator. 29. So we got G. Now, how could we get S? Yeah, remember there's 46 total, right? 46 calculators total. So you could just subtract from 46. 46 total, just subtract the 29. 17 scientific. We're done. How are we doing? We good with the money problem? So it'll be one money problem on Wednesday. Does that make sense? So first equation is just x plus y is number. The second one, you put the money, and the total money.
So they just wanted how much there was of each. They didn't want like how much did we spend on scientific?
No, yeah, they'll just ask for how much of each. How many scientific, how many graphing, yeah. All right. Okay, so there's some 20% and 10% OJ. Mix them together to make 10 liters of 12%. Is that making sense? So we're mixing 2 kinds of orange juice, 2 kinds of juice. One of them has 20% orange juice in it, the other has 10%. We want to make a mixture that's 10 liters of 12%. How much of each should we use? Always do on mixture problems, remember? The bucket beaker things, that's right. Whether you call them buckets or beakers, either way is good. Yeah, the first plus the second equals the final. And you put the percentages in the bottoms and the amounts in the top. So I'll go 20%. Let me change it up. 20%, 10%, the final mixture is 12%. And did they give me any amounts? Yeah, they gave me the 10 liters of 12%, so it goes above the 12%. Is that good? What goes in those other 2 blanks? That's my X and my Y. Okay, so that's a nice drawing, but how do I get my actual, 2 letters, I need 2 equations, don't I? So how do I get my 2 equations out of that thing? Do you remember? So the first equation comes, so number 1 comes from the tops only. Just right across the top. X plus Y is 10. The second equation comes from multiply top and bottom. So 20 times X. And remember, you don't need to make those into decimals, we learned, because you could just get rid of the decimals from both sides anyway. So let's just save some work and forget about decimals. Everybody good today? See how I just multiplied 20 times X, 10 times Y, 12 times 10. Multiply, multiply, multiply. That's how you get the second equation. Now, that causes some people to mess up in the money problem because they get used to that multiplying on the right, lower right corner here, and they try to always do it, and they do it on the money problem, which is wrong. You don't multiply the money problem, you just put the total money. So watch out for that. It's a mistake I see over the years. All right, we have 2 equations with 2 letters. Here we go again. You guys are pros at this now, right? Can you do it? So get X alone in the first equation, plug into the second equation, same kind of thing. Or make opposites if you prefer that method. Either one is good. I'll give you a second. Okay, so I'm going to move this Y over. So X equals 10 minus Y, or negative Y plus 10 either way. So we got X alone. Plug that in for X in the second equation. So we get 20 times X, which is 10 minus Y, plus 10Y is 120, right? 12 times 10 is 120. Is that good to there? Is that making good sense? And now we distribute. 200 minus 20y plus 10y is 120. 200 minus 20y plus 10y is minus 10y. Right, we good to there so far? And now, how do we get y alone? Subtract 200. So minus 10y is, what's that, minus 80? Minus 80. Can you read that okay? Divided by minus 10. So y is 8. So we got y is 8. So what would be the easiest way to get x? Plug in right here, huh? X is 10 minus y. X is 10 minus 8. X is 2. So x is 2. Y is 8. Now in the question they might say, how much of the 20% stuff? So if they say how much of the 20% stuff should be thrown in the mix, is that x or y? Yeah, it's because the 20% has got an x with it. You give them the x value too. Well, I said, how much 10%? Well, that's y. You give them the 8. Huh? They might ask for either question. They'll ask for one of those on the exam we take on Wednesday. Good with mixture? So we got money. We got mixture. So there we go. So I ran out of time in lecture, I think, to show you about this kind. So I wanted to definitely show you today. We have 15 minutes. We're doing good. Doing well. So I know I did some travel ones, but this is a special travel one. So first off, what formula do we use in all travel problems? Dirt. Distance equals rate times time. Okay. So, and now, the trick, now when I say this is a special travel problem, what I mean is I didn't have time to lecture. There was some in the homework. I hope you look back at old YouTubes and figure it out. I didn't have time to do one where there was like an object in the water with a current. You know, there's planes in the wind or boats in the river, right? And so what happens? What happens when you're in the water or the air and there's wind blowing or water moving? You know what's going to happen, right? If you're, say I'm in the river, say I'm in the river and I can paddle, I don't know, 3 miles an hour. Say I'm not a very fast, but I can paddle 3 miles. Well, here, let me make me faster. I can paddle 10 miles an hour. If there's no water moving, if it's just still water on a lake or something, right? A quiet lake. Let's say I have no idea if that's fast or slow or what. I have no feel for it. But anyway, say I can paddle 10 miles an hour. Now, if I get my canoe in a river and I go with the current, okay, and I'm paddling as fast as I can, and I can do 10 on my own, and the current's, let's say 3 miles an hour. It's a slow current, 3 miles an hour. How fast am I going to go downstream? Downstream. When I go with the current, right? That's downstream with the current. I'm doing my 10 miles an hour paddling. The current's pushing me an extra 3. I would add, and I would do 13. You would add, huh? But what about when I turn back and I got to come back upstream? Fighting, I'm doing my 10 miles an hour paddling. The current's fighting against me 3 miles an hour. How fast am I going to go? Yeah, minus the 3, I'd only go 7. Right? So you add when you go downstream with the current, and you subtract when you go upstream against the current. Well, that's exactly what we have to do when you're a plane in the wind or a boat in the river. So here we go. So 5 kilometers per hour. So the first thing you should do on a dirt problem, a travel problem, where there's a current. So that's what's special. This is not just any old travel problem. This is travel problem with a current, wind or water. What you always do is you go, okay, we got the boat plus the current and the boat minus the current. Makes sense? My boat speed plus my current when I am with the current, and my boat speed minus when I'm against it. Makes sense? The 2 rows become with it and against it. And the width is plus, your width of current adds to your speed. The minus is when you're turned around fighting against the current going upstream, and it slows you down. Does that make sense? So you always begin that way on a current problem. Travel with current involved. Okay, so let's put in the numbers now. What are they telling me? 5 kilometers per hour, same thing as 5 miles now, right? Just kilometers, is the current. So where's that go? Well, that's the C. That is the C. That's the current. I don't need to use a letter anymore. The mystery's over. It's 5. The current is. I don't know how fat, what the B is yet, but I know the C, the current, is 5. Right? So Alvin goes B plus 5 when he's with the current. It adds 5 to his speed. And however fast Alvin can paddle minus 5 when he goes against it. That makes sense. The current's 5. Okay, what about the 2 hours? Is that a distance, rate, or time? That's a time. Now, is that a time here and there, one or the other? Oh, 7 hours back. So, do I have it that way, or to go the other way? 7 hours is against it, so that's the trip back. That's the slower one. It's fighting against it. It's a lot longer. Right? All right. Remember how this works? You get the 4 boxes on the right. I've got the 4 boxes on the right now. And how do you get the 2 boxes on the left, the 2 D boxes? Multiply. Look at the relationship. D, these aren't just 3 letters that are unrelated. They're related. The D equals the R times the T, huh? The D box is the R box times the T box, isn't it? So it's R times T. So I'm going to put the 2 in the front. 2 times B plus 5 and 7 times B minus 5. Does that make sense? I just multiplied those, right? Because it tells me how these boxes relate to one another. The D box always equals the R box times the T. So the D is R times T and the D is R times T. Okay, so what? Now what? Remember, then you always pull out these 2 boxes. And you're either going to set them equal to each other, or you're going to add them. You're either going to put an add or a minus or an equals between them. If you add or subtract, then you got to equal a different number. Is there another number in this problem anywhere? No. We've already used all the numbers. There are no other numbers. So remember what I said always happens when there's no other numbers?
Equal.
You always set it equal. Now that's not logic. Let's have a logical reason also. Yeah, because it's the return trip. It's the same distance. Huh? It just takes longer. But the distances are the same. You're going between you just went wherever and then you came back. So it's the same. These 2 distance boxes have to be equal, don't they? The distance doesn't change. So that's why they're equal. Now we can solve for B. The good thing is we only have 1 letter. So let's solve it for B. Distribute 2B plus 10. Distribute 7B minus 35. Good. How do I finish getting B alone? Yeah, either one. I'm going to get rid of the 2B. It doesn't matter. You always want to do the letters first, though. Don't do the 10 or the 35. First do the letters. Get rid of one of them, right? We don't want them both. So then we would have 10 is 5B minus 35. I'll erase this and finish up this problem. We're almost there. Trying to solve for B, the boat speed. What's next? And 35. Boom. That's what, 45. Divide by 5. B is 9. Is that the answer? Now, careful on a word problem. You always want to make sure you're really answering their question. Is that what they want? Well, find the speed of the boat in still water. That's boat, yeah. That's how fast the boat goes in still. Why do they say still water? What's up with that still water? Yeah, not moving. That's the boat alone, with no help or hindrance from the current. That's the boat alone. Yeah, that's what the B is. It's the boat alone. Alvin can paddle 9 miles an hour on his own in still water, on a lake or something. All right, sorry, I better move on. I know it'd be great to talk about it for even miles an hour. If it had gone 10 miles an hour faster, it could have made the trip in a half hour less time. How far? I remember doing this one with you, didn't we? A week ago or something like that. So try that one again. So this one doesn't have a current. No, so there's no water or wind. This is an easier dirt problem. No current. Don't have to worry about boat plus current and boat minus current. Or plane plus the wind, plane minus the wind. Don't have to worry about that. It's just straight ahead dirt. So go ahead, do the dirt for me. You got to get the 4 boxes on the right. Okay, car travels from one town to another 50 miles an hour. So 50 miles an hour, is that a distance, rate, or time? That's a rate, that's a speed, huh? 50, that's the rate. Oh wait, we don't know that's the rate for both. If it had gone 10 faster, what rate would that be? 60. If it had gone at 60, right? 10 faster. It could have made the trip in half an hour less time. What do I do for time? X minus 0.5, and this is X. So that makes sense. Why 0.5? You don't want to put in 30 because we're talking hours, not minutes. How do I know we're talking hours? Well, because this is what? 50 miles per hour. So as soon as you use 50, which is miles per hour, you're committed to hours. You can't switch out to minutes. Everything else has got to be in hours as well. So half hour, I just use the 0.5 hours. Now, why minus? Because it's less, right? If we'd gone faster, we'd have half hour less time. So whenever they say one thing is half hour less, that's X and X minus 0.5. Is that good? Can you finish it from there? We have 4 boxes. You know how to get the 2 boxes on the left and what to do from there. Okay, so this is 50 times X. 60 times X minus 0.5. We good there? Distance equals rate times time. And then what are we going to do with those 2 boxes? Are there any other numbers here? No. So we're going to set them equal. And why would they be equal logically? It's the same trip. We're just talking about if they'd driven faster. Right? The distance wouldn't change. All right, solve for X. That's going to be 30. So to finish getting X alone, I'm going to subtract 60X from both those. Gonzo. Get minus 10X is minus 30. Last step, divided by minus 10. X is 3. We got it. 3. Is that good? Uh-oh. Wendy's not happy. Whenever Wendy's not happy, it's good to listen closely. Wendy knows what she's talking about. Probably some of you aren't happy too. Something's wrong, huh? Good. Yeah, watch out. I see this mistake a lot. I don't want you all to make it. I'm trying to save you by doing these goofy things. Do whatever I can. It'll stick in your mind. So I'm not doing the Charlie Brown 111 teacher. Are you hearing me on this? A lot of people do fabulous work on a travel problem, get all the way to the end. Excellent job. set it up well, solve it well, get their answer, and then they look at the options. You know, it's like just A, B, C, D, E. There's always that none of the above. And then option B or whatever, have 3. They just circle 3, next problem. That would be a bummer to do such good work and right at the end miss it. Why? What am I doing? Well, look at what the question was. How far apart? So remember, X is not always the answer to a word problem. That's the key. It'll unlock any of those 6 doors. You can find anything now, but make sure you give them what they want. What do they want? How far apart? Is that a distance, rate, or time? They want a distance. They want you to, either one. You can plug in either one. Let's do the easy one. I'll put the 3 in right there. They want 50 times 3. 50 times 3, which is 150, and that'd be down here, option C. Or I'm just saying, they always put the false answer. You know, I grabbed the publisher's test, that publisher test bank thing. So those dastardly publishers, they always put in that other answer as an option. Watch out for that. Don't be fooled by that. Does that make sense? Sometimes they give that, yeah. So everybody see. So make sure you answer the real question on that.
So then you plug it in for X, and then
Yeah, you plug it in for X, and then you've
150 miles.
yeah, because they want a distance. How far they want. So you realize you need a distance box. Plug in for X in the distance box. Comes out 50 times 3, 150.